Greetings. We are in Unit 5, Module 1. This is Session 4. The name of this home connection is Angles and Rectangles, page 1 of 2. It's a two-pager. Put your name and number at the top and get credit for your hard work. Let's dig in. Alexis put two 90-degree angles together to make a new angle. How many degrees does the new angle measure? Please do not forget that our 90-degree angles are the ones that are square. Okay. If I were to put two of them together, maybe I'll flip the other one back to back so I have them kind of sharing the same side. So I've got a 90, I have a 90. Put them together and you should have what? 90 times 2 is 180 degrees. Now, hopefully you can see, if I drew this well, I could even use a ruler and make it look very straight, is that when you put two 90s together, you end up with a special kind of angle. A 180 degree angle, which is exactly what we have, is called a straight angle. Okay? Now, if they weren't right angles, we would not end up with this perfect situation where we would have this lovely straight line. But in this case, two 90s will always make a straight line. We love it when things are square. But what if you put three 45s together to make a new angle? And you could say that, two 45s does make a square, because two 45s is exactly, is exactly 90 degrees. But if I put a third one in, that's where you have to do some clever math, okay? And you could just multiply it if you wanted to do standard algorithm. Put the 3 on bottom, 5 times 3 is 15, carry the 1. 4 times 3 is 12, plus 1 is 13, you get 135. You could even stack it and add it. You could do 45 plus 45 plus 45. You get the same answer. Or if you remembered that two 45s is 90, you could just do 90 plus 45. You're going to get the same answer. And you can be as creative as you want. But 135 degrees is our answer there. What kind of angle did Henry make? Okay, we'll take a look at what we have here. And if you want me to kind of get rid of all the things, let's say that it comes down to this point here. This is going to be pretty close. I do have a protractor by me, but I'm going to just eyeball it. That's the angle that we're measuring here. It is more than 90, but it is less than 180 degrees because it's not a straight line. If it were a straight line, I'm going to use a different color here, I would kind of have, it would kind of look like that. Kind of made it dotted. So we're more than 90, less than 180. We call that an obtuse angle. Oh, now Austin's going to put four 15-degree angles together to make a new angle. I kind of just want to do the algorithm. 15 times 4. 4 times 5 is 20. Carry the 2. 4 times 1 is 4. Plus 2 is 6. 60 degrees. Oh my goodness. Well, that's interesting. Well, let's go ahead and just draw this out. So if I do my dot here, I'm going to place this on the center. I'm going to do some protracting. Yay! Okay, let's see. Oh, mine is upside. It's kind of hard to do this if it's upside down. And then I'm going to count up to 60, put my thing here, and I'm going to measure. So this is exactly, well, as exact as my compass can be. That is a 60-degree angle. Okay? And we need to know what kind it is. Well, rights are exactly 180 degrees. Obtuse is greater than 180 degrees. Or excuse me, I'm labeling all of these wrong. Right angles are 90 degrees. Straight angles are 180 degrees. Obtuse angles are more than 90, but they're going to be less than 180. And acute angles are less than 90. So what do I end up with? This is 60, which is less than 90. Oh, it's such a cute angle. It's acute. All right, Claudia drew and labeled this rectangle. It's a miniature picture. You're going to answer some questions about it. What is the sum of the four interior angles? Interior means inside. So I'm looking at this this, this, and this. We know that if you have a square or a rectangle, these are each 90 degrees. 90, 90, 90, 90. What is the sum? That means you're going to add all of those together. Show your work. I'm going to let you answer that on your own. Pause this video whenever you need to. The perimeter of Claudia's rectangle, we did this just recently. So we have side plus side plus side plus side. Don't forget to label it in centimeters. Okay? Pause this video. Do that question. What is the area of Claudia's rectangle? That is how tall it is times how wide it is. And you're going to give your answer in square centimeters. Don't forget, when you're talking area, your units are square units. Claudia colored half of her rectangle blue. Oh my goodness. Oh, which half? Oh, that's tricky, but that's okay. We'll do it this way. She colored half of it blue. I should probably use blue. What is the area of the blue part of her rectangle? Oh no! This might seem a little harder than it is. What does this say? 43 tall, and that's going to be a fraction here, isn't it? I believe that's, what is that, 18 and a half? 18.5 or 18 and a half? Half of that. Are you going to take 43 times 18 and a half? Oh, I don't know if I would do that. But what I might do is like this half is really important. Why don't you take, and I am going to let you do this on your own, take the area that you got from the original rectangle. So whatever your answer was here, okay? Take that answer and cut it in half. Because you did, she colored half of the rectangle blue. It's going to be easier to split that number in half, to divide it by 2, whatever that number is, divide it by 2, and you'll have your answer. It's going to be a little bit easier to do that than to multiply times a decimal. We could, it's just a little bit harder, and it's not worth our time. Okay, so dig into that challenge problem. If you do have more questions, please ask a math wizard. Math teachers love to answer questions, and so do just your friends and family that enjoy math. They love to help out. Enjoy, take your time, re-watch whatever you need to watch. Good luck.